So today now we're gonna talking about the application of resonance. How do we use the resonance? Application of resonance. So there are actually five application of resonance. First is the comparison and calculation of bond order. How do we compare and calculate the bond order? And second is plus mesomeric and minus M. That is called the mesomeric effect, and plus R and minus R. Third is aromaticity. And fourth is the stability of intermediates. What are the intermediates? The stability of intermediates. The intermediates are those substances which form, those species which form during the course of the reaction, and are called the reaction intermediate. And heat of combustion and heat of hydrogenation, heat of combustion and heat of hydrogen. So these are the major five application of resonance. So first of all, let's talk about comparison and calculation of bond order. Very first application, comparison and calculation of bond order. How do we compare and calculate bond order? So what is actually bond order? That is the number of bond between two species, right? Bond order is the number of bond in between two atoms, and like CH3 or single bond CH3. Here bond order is 1. CH2 double bond CH2. Here bond order is 2. HC triple bond CH. Here bond order is 3. So like here bond order is 2, and here also the bond order is 1. And bond order is inversely proportional to the bond length. Bond order is inversely proportional to bond length. And what are the other comparison like bond order? Is inversely proportional to bond energy. Bond energy and inversely directly proportional to bond energy, and directly proportional to the bond stability. How does it means? It means that when we have a single bond, it could be easily breaked, right? When it could be easily break, so bond order, the bond length is the bond energy is also less, and bond stability is also less, but bond length is more, because triple bond, the bond length is short. Here the bond length is shortest. In case of the triple bond, the bond order is shortest, here longer, and here longest bond, right? So higher the bond order, less will be the bond length. That is important point. Now let's try to figure out how do we define the bond order. How do we define the bond order? How do we calculate exactly the bond order? First of all, let's talk about in equally contributing structure. Equally contributing structure are identical resonating structures. So an identical resonating structure like SC double bond O and O negative, here it will be form a resonance structure O negative and then double bond O. Here bond order is summation of total bonds divided by summation of resonating structures. So bond order comes out to be 2 plus 1 total bond in between any two elements. Suppose if I fix this bond, the total bond is here 1, 2 and 3. So total bond is 3 divided by resulting structure are 2. So it is 1.5. The bond order is 1.5. That's how we define the resulting structure only in case of identical or equally contributing resulting structure. Like one more if we see, like one more, C double bond O and O negative and O negative. C double bond O, O negative and O negative. C double bond O, O negative and O negative. Here also let's fix any bond. 1, 2, 3, 4. 2 plus 1 plus 1 divided by 3. So here it will be 4 by 3. Let's talk about other resulting structures. Now I am drawing, just try to figure out the bond order of carbon and carbon. I am just writing the which bond order you have to identify. R double bond S O negative. And bond order of sulfur oxygen. And here also negative charge. Bond order of carbon carbon. Right. So you might get some shortcut formula, but we are using the traditional method to figure out the bond order. So here let's talk about these three bonds. Pause the video and try to answer by your own. So let's draw all the resulting structure over here. So the one more resulting structure will come out to be like this, and one more resulting structure will come out to be like this. So bond order will be fix any bond 1, 2, 3, 4, 5. We have to fix these two bonds. Any bond you have to fix. We have fixed now add the total number 1, 2, 3, 4. So it will be 4 by 3. Now here also draw all the types of resulting structure. Now to draw the resulting structure, first of all R S O negative or double bond O double bond O. Here also R S O negative double bond O double bond O. Bond order must be let's fix any two bond 1 and 1, 2, 3, 4, 5. It will be 5 by 3. Here also let's draw all the resulting structure. So this bond will come here, this will come here, negative charge. This bond will go here, it will go here. Negative charge. This one will go here, it will go here. Negative charge. This one will go here, it will go here. Negative charge. This will go here, this will go here. Negative charge. So bond order. Fix any two bonds. 1, 2. We just fix any two bonds and try to. These two are 1 and 2, 3, 4, 5, 6. 1 and 6 are identical, so we will not include the 6th one. So bond order is 1, 2, 3, 4, 5, 6, 7. 7 total number of bonds divided by 5. So 7 by 5 is the bond order. Now I am giving you some more practice problem. So you have to again pause the video and try to answer by your own. Next question, Cl double bond O double bond O double bond O negative. Bond order of ClO. Next question, P double bond O negative and O negative. Bond order PO. Next question, benzene. Next question, CH3 O negative. Right, and one more bonus question you have. NH2 CH double bond NH2 plus. So these are the question. Try to answer by one. Pause the video. So now let's jump into the solution. So if you draw the resulting structure, it will go here and go here. ClO negative double bond O double bond O double bond O. It will go here and it will go here. Cl double bond O. Cl double bond O negative double bond O double bond O. It will go here, it will go here. ClO negative double bond O double bond O double bond O. Right, so how many structure we have? First, then it will repeat fourth. So how many structure we have? 1, 2, 3, 4. And let's fix any two bond. Let's fix these two bond. 1, 2, 3, 4, 5, 6, 7. Here also the order will be like 7 by 4. phosphate P O negative, double bond O negative, and O negative. All where the double bond will come O negative, and all where P double bond O negative, O negative, and O negative. So bond order is 1, 2, 3, 4, 5. 5 by 4. Here bond order will be 5 by 4. Here benzene resonating structure. So its benzene resonating structure will be 1, 2, 3. So bond order is fixed any two bond. 1, 2, 3. 3 by 2. It is 1.5. CH3CO negative, it will go here, it will go here. So CH3, CO negative, double bond O. So bond order, fix any two bonds. 1, 2, 3. 3 by 2, it is 1.5. Here also we have lone pair. It will go here and it will go here. It will form NH2 double bond CH NH2 and lone pair. So bond order, fix any two bonds. 1, 2. First of all, we have to fix that bond for which the bond order it is been asked. So here the bond order is asked is bond order of CN. So 1, 2, 3. 3 by 2, which is 1.5. So finally we have done that. We have calculated the bond order in equally contributing structures. That is done. Now what about unequally contributing? The second the question arises like in unequally contributing resonating structure. What about that? Unequally contributing resonating structure. So in order to identify unequally contributing resonating structure, first of all, understand we cannot calculate exact value. We can't calculate exact bond order in unequally contributing structure. We cannot calculate the exact bond order in unequally contributing structure. We can only compare. We can only compare bond order and bond length and bond energy, whatever we had. We can only compare. How? How can we compare? So let's talk about first. We have two structures which are forming an unequally contributing resonating structure. It will go here and it will go here. CH2 double bond C O negative and H. Now let's go by traditional method of equally contributing. We have to find the bond order of carbon and carbon. So let's say here it is A and here it is B. Let's say here it is A and it is B. So bond order according to traditional method, fix any two bond 1, 2, 3, 1, 2, 3, 3 by 2, which turns out to be 1.5. Now this is 1.5. But that can't be exactly 1.5. For A bond order is 1, for B bond order is 2, and for equally contributing it should be 1.5. But these two structures are not in equally percentage. If we talk about like if we give it name A and B, so percentage of which is more, A and B. We have seen that B is more stable resonating structure. We have just saw the stability of resonating structure, and we saw that the negative charge is on more electronegative element. So B has oxygen on it. So percentage of B is more than percentage of A in the structure. So B has a double bond tendency, so it will be. So B has a double bond tendency, right? And B has double bond tendency, and A has single bond tendency. So it will be more shifted towards the double bond. So here it will like this. Bond order will of C single bond C like here, lies here. Why? Again, let me explain you. First of all, we have to draw all the possible resonating structure. Then we will be then we will be treating it same as the equally contributing. When we will treat it as same as equally contributing, so So what will happen? It will happen that we get the approx bond order, but it is not equal to that bond order, and it's not equal. It could be here this side, or it could be here this side. So we have to decide when it is inclining. So when A is stable, so it will incline on left hand side. When B is stable, it will incline on right hand side. So we know B is stable, so it will incline on right hand side. So it will be somewhere between 1.5 to 2. It will more closely to 1.5, but we can only compare the value, right? So that's how you have to identify. I'm writing some question. You have to identify the bond order. I'm writing some bond order like alpha, beta, and I'll give you time to try to answer by your own. Like Cl, its bond order is alpha. I'm writing the bond order, right? First, and it is beta. Second, here it is alpha. It is beta. Third, it is alpha. It is beta. Fourth, it is alpha. It is beta. Fifth, alpha. Here it is beta. Here it is gamma. Now you have to compare. Now you just have to compare the bond order. Now let's talk about very first question. We know that chlorine has a lone pair and it is involving in resonance. So alpha has double bond character. There is a structure, which have Cl plus and O negative, the C negative. So here adds some double bond character. So its bond order must be greater than 1. Or eventually it will be near to 1, and we can figure out, but approximately it is greater than 1. Not approximately, it is greater than 1. Approximate value we can figure out. But right now we are only comparing. So bond order is greater than 1. So alpha and beta, if we compare, so beta is single bond, alpha double bond. So bond order alpha greater than beta. So where the resonance is occurring, there it has a tendency to occupy multiple bond. So here also bond order alpha greater than beta. Here also resonance happening is alpha greater than beta. Here also resonance happening. When here resonance happening, so it has single bond character now. Single bond character means its bond order is less than 2, and its bond order is exactly 2. So here it is beta greater than alpha. Here bond order is 1, here 2, here nearly 1.5. And because resonance will happen, so it will form a structure like this. So nearly it will be 1.5, and it will be more closely to 1. So bond order here it will be much in between 1.25 to 1.5. So the bond order is beta, and then gamma, and then alpha. So now I'm putting more question to practice it more. So here let's talk some more questions. We have done 5 questions. Now let's talk about 6th question. The 6th question says this bond and this bond and this bond, alpha, beta, gamma. 7th question says we have this bond and we have that OH, and this is alpha and this is beta. 8th question says we have CH2 double bond CH2 and CH2 double bond CH and O negative. We have alpha here, we have beta. 9th question says we have and we here the C alpha and beta. 10th question says alpha, beta. Now we have to compare all these values. Now here bond order is 2, here nearly 1.5, and here it is 1. So alpha greater than beta greater than gamma. Here it is going in resonance. So beta has single bond character. Single bond character also. So here it will be alpha will be greater than beta. But here also it has single bond character. This bond has single bond character, so alpha will be greater than beta. This beta is actually a double bond. It is not going in resonance, but it is going in resonance, so it is a single bond character. So beta greater than alpha. Here alpha do not have any resonance. Beta has single bond character also. So alpha will be greater than beta. So these are some good questions. Now move to some more advanced questions which are quite good. We have covered all the types of question in our series, from basic to very advanced, as much advanced as you can see. So like 11th question we have double bond O and this bond and double bond O, and here we have double bond O. Here we can give it alpha, beta and gamma. Now 12th question, C double bond O H and C double bond O H. It is alpha and it is beta. 13th question, C double bond O negative and O negative, and CH2 CH and O negative. And now it is alpha and it is beta. 14th question, and it is a good question. We have two cyclohexane ring, cyclohexene, this and this. Here we have alpha and here we have beta. Now you have to try to answer by your own. Pause the video. Now here it is we gonna single bond character, but it is a greater extent, so single bond character is more. Here the resonance is less extent, so single bond character is less, and it is bond order 2. So it will be alpha greater than beta greater than gamma. Again bond order is exactly 2, so beta greater than alpha. Here also the bond order we have calculated, but here it is nearly 1.5, and it was here 3 by 4 by 3, which was nearly 1.3. So we know beta greater than alpha. Now, if we talk about this question, the extent of resonance is here is more. The extent of resonance is more, but here the extent of resonance is less. So it has more single bond character. It has more single bond character, so beta will be greater than alpha. So let's see 4 more questions. We have done 14 question. Now 15th question, let's see. NCH3, CH3, NCH3 and CH3. Here we have NCH3 and CH3. Now what will happen here? It is alpha and beta. Just think by your own. I'm just writing some more questions. And double bond O, and here we have double bond O. Here we have alpha and beta. 17th question, alpha beta. 18th question. Now 18th question is 17th question, alpha beta. Here it is gamma, and here it is delta. Now here we have seen that that there is lone pair, and lone pair will donate its electron, but due to that NS3 will turn out of the plane. It will become non-planar with benzene. It has no planar with, because due to that bond will tilt out. This is a different plane and this will be in perpendicular plane. Right, due to that steric index, we will particularly see when we will study the steric inhibition in protonation, SIP. Just wait for that part. Just remember, due to that, when they both groups are coming out, due to that nitrogen and CH3 groups comes out of the plane. So when it comes out of the plane, there is no resonance between them. So it has a single bond only, and it has partial. You can say it has partial double bond. So now alpha is greater than, so partial double bond and single bond totally. So beta will be greater than alpha. Here also extent of resonance is more. Here extent of resonance is less. So here we could say single bond is more, and here double bond character is more. So alpha will be greater than beta. Now if we see that alpha has 1.5 bond order, beta has 2 bond order, and gamma has 1 bond order, and it will be lie in between somewhere. It will form a resonance, positive and negative, and bond order will lie somewhere between 1.5 5. But where it is from 1.5, 1, 2 and 1.5, A and B. So we can say that A is more structured, A and B. A is more stable, so it will move towards the 1 to 1.5. So the bond order will be beta greater than alpha, then delta, then gamma.